Welcome to the online lecture series of refrigeration and air conditioning. Here is Professor Lakshman Manu. This is a video session on adiabatic mixing of air. In this session, you will be able to explain adiabatic mixing of air and mass and energy balance equations. Adiabatic mixing of air: when two quantities of air having different enthalpies and different specific humidities are mixed. The final condition of the air mixture depends upon the masses involved. So here in this diagram, it is shown that this is an outdoor air, or we call it as fresh air. This air is mixed with recirculated air, which is also called as room air or return air. So fresh air is indicated by point number 1, return air is indicated by point number 2. These both airs are mixed here in a processing unit, that is mixing chamber. After that, this is a point number 3, that is condition of mixture. This air is passing to the room, that is condition room. So this is a supply duct. Condition room, that is indoor condition, that is indicated by point number 2. So here two air streams, stream 1 and 2, are mixing adiabatically. So these are the parameters for air stream 1, that is M1, H1 and W1 are mass, enthalpy and specific humidity. Similarly, for air stream point number 2, its parameters M2, H2, W2. These are the parameters of mixture, means at point number 3. So assuming no losses of enthalpy and specific humidity during the air mixing process, because the name is adiabatic mixing, here mass balance is M1 plus M2, means stream 1 air mass, stream air 2 mass, that is equal to mass of mixture M3. Energy balance is given M1 H1 plus M2 H2 is equal to M3 H3. For mass balance of water vapor, the equation is M1 W1 plus M2 W2 is equal to M3 W3. Here now putting value of M3 from equation 1 into equation 2, we can have this equation: M1 H1 plus M2 H2 is equal to this M3 we replace by M1 plus M2 into H3. Further simplification, M1 into H3 plus M2 into H3. Then we take together terms of M1. So we find here M1 into H1 minus H3 is equal to M2 into H3 minus H2. So here ratio we find M1 upon M2 is equal to H3 minus H2 divided by H1 minus H3. So this is a ratio as far as enthalpies are concerned. We can get this ratio by putting value of M3 in equation 3, means in the form of specific humidities. M1 upon M2 is equal to W3 minus W2 divided by W1 minus W3. Also we can have here this ratio in the form of temperatures. So M1 upon M2 is equal to TD3 minus TD2 divided by TD1 minus TD3. So from this we can understand that mass of entering air 1 and this is another air 2. These two masses M1, M2, this ratio is equal to differences in either enthalpies or specific humidities or variable temperatures. Now here you can see that M1 mass is in a proportion with difference which is on the opposite side of the line, this 3 minus 2 you can see here on in all these formulas, while this m2 mass is in a proportion with difference in other side of the point between 1 and 3. For the better understanding, you can apply this concept to write the equations. So at the end of this session, we can explain adiabatic mixing of air and mass and energy balance equations. If you like this video, please subscribe and share. Thank you.